ejemplo, vamos a ponerlo así. Capaz
Okay,
él,
we're recording. We will stop
pero por cómo
much
habla, va
early,
a
so
entender otra
those of
cosa
you
que
who
no
are
es.
here can look at what you missed on the exam.
Yo le digo, o sea, y él
On
dice mil cosas, pero lo que hace
Thursday, people who
parece.
are here. Your grade
Así dice.
has been posted to Gradebook. I said you've already seen that. There was kind of a curve in what was posted because you recall I had too many questions for the answer sheet. There were 7 extra ones. And as I've looked over those last 7 questions, as people weren't doing too well on those. So what I ended up doing was just taking your Scantron score, which was the percent you got right on the first 50, and then whatever you got right on the last 7, that was added as a bonus. So that's what you find on Moodle, and the high score was 99. The low score was in the 50s. The median was, I believe, around 80, which is high for economics. So that's good. That's good. I hope it goes up on the next exam. If you have not been submitting your MRU notes, I really strongly encourage you to do that. That can help you a lot, and you can still allow you to do that. Also, another thing I wanted to point out on the learning curve activities, keep in mind that your score on the learning curve is 0 or 100. Okay? There's a target number of points you have to reach, and your score is 0 until you hit that target point at which it goes to 100. And I haven't I haven't closed those yet, so I recommend that you go back and look at all your learning curve activities and make sure you have 100% there. Because if you don't have 100%, you have a 0. And as soon as I officially close it, then it's going to show up as a 0. So, and I'm going to do that this weekend. So make sure that you have completed, because you may have gotten almost to the target. You thought, well, I'm done. But no, it's important to get to whatever that target is. Let me also remind you of how your semester average is calculated. You can still improve your grade if you're not doing too well. Remember, your exams count as 80%. This is in the syllabus. You'll see this equation there. You take your exam average multiplied by 0.8. You add to it your sapling average times your attendance factor, which is 1 if you're always here, 0.75 if you're here 3/4 of the time, and so on. And then that's multiplied by either 0.20, 0.24, or 0.26, depending on whether you qualify for the bonus. Remember, you have to qualify, you have to have your sapling average up at least to 80%, 90 is better, get a bigger bonus, and you have to turn in your MRU notes. Right? Any questions at this point? Okay. Well, we will go on into chapter 31. Let's review what we've done so far. We are definitely building. Remember a while back when we started chapter 26, I believe, we said 3 main macroeconomic goals that we would like to see achieved in the economy. We'd like to have economic growth, we would like to be at full employment, and we would like to have price level stability, as you see here. And we spent a lot of time developing GDP, because that is the main measure that we use to assess whether the economy is actually growing or not. And if we know if we can measure how the economy is doing, then we have a way of assessing policy. If we put into effect different policies, and then things change, then we can try to figure out, well, did that policy change cause the change in GDP? If we don't have some way of measuring how we're doing, then when we change policy, we don't know, was that beneficial or was that harmful? Obviously, we've got a presidential election today. We have what kind of policies will be imposed depends on who wins the election. And those policies will have an impact on GDP, the economy, standard of living. So without GDP, it's really very hard to assess how things are going because the economy is so complex. You can't just look out the window and say, well, looks like things are going pretty well. They may be going well here, but what about all the other communities in Louisiana? What about all the other states? Somehow you have to take all those different areas and come up with a number that represents what's happening in general. We said GDP does that for us. Full employment, we said we want unemployment to be as low as we can sustainably get it. And we developed the unemployment rate. We developed the labor force participation rate. That helps us assess how close we're getting to full employment. We said, even at full employment, we still have some unemployment. And the unemployment we have at full employment, what did we call that? The natural rate of unemployment. So if we have a knowledge of these things, it gives us a way to assess how we're doing as far as the goal of full employment. But now this third goal, price level stability. How do we assess whether that is occurring? Well, that's really what we are looking at in chapter 31. Inflation and the quantity theory of money. This is a really useful chapter, okay? Because inflation is something that can be devastating to people when it happens. We haven't had a lot of inflation recently, in recent decades. Can we have more in the future? Yes, that's certainly a possibility. The whole idea of the quantity theory of money is that there is a connection between the amount of money that is created and inflation and prices. And the Federal Reserve is doing some very interesting things these days. Is it going to lead to more inflation? Can it lead to a lot more inflation? Some people would say yes. People say no. How do you assess who's likely right? Well, this chapter will give you a framework for understanding these issues. And, I wish I could say when we get to the end of this chapter, we'll have a very clear answer. We won't. They're very smart people who think that we should be concerned about inflation and very smart people who think we don't need to be. So we won't have a simple answer, but you will understand the variables and what's involved much better after we get through this chapter. Things we're going to be looking at in this chapter. What is a price level? That's important. What is the inflation rate? How is it measured? Very important to recognize that the price level and the inflation rate, those are closely related things, but they're very different. We'll explain exactly what that difference is. We'll talk about the quantity theory of money, and we will talk about the cost of inflation. You might think, well, the cost of inflation, isn't that everything costs more? Well, not exactly, because when we have inflation, generally prices in general are going up, which means when you go to the store to buy stuff, you have to pay more. But during periods of inflation, people's incomes are going up at the same time. So if you've got 10% more money and prices are 10% higher, should we say, well, it doesn't really matter? Right? There are people who say that. Our book will argue, and I would agree that that's not the way to look at it. Inflation is a very serious problem when it gets very high. Okay, to help us think about what the price level is, what a price index is trying to do, this is a very useful chart. Okay, so what do you see here? You see a guy with a shopping cart, and in the shopping cart he's got a lot of different things. A price index is simply trying to measure how does the cost of some basket of goods change over time. So here, this is hypothetical data. This is not realistic. Here, this is saying that in 1915, to buy these goods, you would have had to spend $10. This is telling you that 50 years later, 1965, to buy exactly the same goods, you would have to spend almost $37. So you're buying the same stuff, but you're having to pay more for it. Obviously, prices on average have gone up. This is a 1985, buy the same basket, it's going to cost you $100. Think of it as you're in Walmart, you got your shopping buggy, you fill it up with the stuff you want to buy, you go through the checkout, and you see what it's going to cost you. But then you go back through and they reprogram the checkout to use prices that existed in a different year. And you scan everything through again, you get a different number. Prices are different. That's essentially how a price index is calculated. They decide, what are we going to put in the basket? And then they look at the prices that existed in different years, and they figure out what you would have to spend to buy that same basket of goods. Okay? So if we take the numbers we have here, we could calculate a price index. Okay? Now, what should be included in the basket? Well, that is a question that's answered by the Bureau of Labor Statistics. You ever hear of the BLS? That's what that's referred to, the Bureau of Labor Statistics. And they employ a lot of economists and a lot of statisticians. They look at all the things that people buy, and they have classified all of those things into 200 different categories and 8 major spending groups. Okay? And these are the 8 major groups. You don't have to remember all these groups, but just to give you an idea. Okay? Food and beverages, housing, apparel, transportation, medical care, recreation, education, communication, other things. Okay? What they are trying to do is figure out what does the typical American family purchase? What are the goods and services that the typical American buys, typical American family puts into their budget? Notice it's not just goods, it does also include services such as medical care, education, things like that. Okay? So it's very complicated in what they have to do. They have to look at everybody in the economy and try to figure out what is the typical family buying. So doing that's very complicated, but the basic idea is pretty simple. What does the typical family put in their buggy each month? And if you want, this just gives you the same thing, but it gives you some examples of the things that are included in each one of these major components. Again, you don't have to remember these components. I wanted you to see them. You do want to remember the key idea, which is they want to put into the basket the goods and services that they believe the typical American family buys. And how much of each thing they put into the basket depends on how much of the thing that they bought, what fraction of their income they spend on that good. To calculate the CPI, CPI stands for the Consumer Price Index. That's not the only price index. I'll very briefly mention a couple of others, but this is the one that you will hear the most about. It is the one that is used most often, the Consumer Price Index. And to calculate the CPI for any year, I'm going to say any given year, there's whatever year you want to look at. Okay? The CPI is a very simple concept. It's just a ratio. In the numerator, you have the cost of the basket that the BLS has chosen, what it costs to buy that basket in terms of the prices that existed in that year. So if we wanted the CPI for 2005, then in the numerator we would be asking, what does it cost to buy that basket in terms of the prices that existed in 2005? And then the denominator is the cost of the same basket, but in terms of the prices that existed in the base year. To count, remember we touched on the base year before. We said anytime the government calculates a price index, they have to pick one year to serve as kind of the reference year. They can compare everything else to that one year. So the government makes that decision, and then they use that for a number of years. Now, eventually, they will revise all of their data, and they may pick a different base year. But for our purposes, once they decide on the base year, it's the base year for all of their calculations. So notice the CPI is just a ratio of the cost of the basket in terms of the year, the prices that exist in the year you're looking at, over the cost of the same basket, but in terms of base year prices. And then you multiply that ratio by 100. Okay? So let's say that we've decided to use 1982 as the base year. Okay? So the denominator is going to be the cost of the basket in terms of 1982 prices. If we now want to calculate the CPI for 1982, then what's the numerator going to be? It's going to be the cost of the basket in terms of 1982 prices. So what is the CPI for 1982 going to be? The numerator is the cost in terms of 82 prices. The denominator is the cost in terms of 1982 prices. So if you divide the numerator by itself, what do you get?
1.
You get 1 for the ratio, and then you multiply it by 100 and you get 100. We can say, and this applies to every price index, whatever year is chosen as the base year, the price index is going to have a value of 100. So if 1982 is the base year, what's the CPI in 82? It's 100. If they decided, no, we want to use 95 as the base year, then the CPI for 95 would be 100. Now, that's a very useful thing to remember. And it should make sense to you because the CPI is just telling you the cost of the basket in one year relative to what that basket cost in the base year. So if you're looking at the base year, then obviously the cost in the base year is the same as the cost in the base year. This is 1, and that gives you a CPI of 100. Okay? You could have a question. where you're given a lot of data and you're told the CPI is 1990, or the base year is 1990, and you're asked to calculate the CPI for 1990. You wouldn't have to do any calculation. You just say, well, that's the base year, so I know it's going to be 100. So let's take that data we were looking at, the drawing of the shopping cart, where it gave us, for these different years, it gave us the cost of the basket. So what would the CPI be if we're going to use 1915 as the base year? What would the CPI for 1915 be? It's going to be 100, right? Because the numerator would be the cost in terms of 1915 prices over. The denominator would be the cost of the basket in terms of base year prices, but that was also 15. So it would be 10 divided by 10 times 100, and that would give us a CPI of 100. For 1965, how would we find the CPI for that year? Do it the same way. CPI for 65 would be the cost of the basket in terms of 1965 prices, and that would be 36.70 over the cost of the basket when? In the base year, which is $10. I'm sorry? I can't hear you. I'm sorry. Well, you have to multiply it also by 100. Right? And if you divide, that is going to give you 360, or should give you 367. You're just taking 36 divided by 0.7 divided by 10 times 100, and then that is, so that's basically you're multiplying this number by 10, which is going to give you 367. Okay. I'm sorry, I can't. You're saying this number doesn't make sense? Well, it's the 3670 divided by 10 times 100. So that's, once I'm doing my arithmetic wrong, that's 367. Okay. We can look at it after class, and I may be doing something stupid, but that's the number I come up with. And to calculate the index for 85 and for 2015, you would do exactly the same thing. For the numerator, you always have, for the denominator, you always have 10, because that's the cost of the basket in 1915, the base year. And then for the numerator, you're going to use the cost of the basket in that particular year, and then you're going to multiply by 100. So if you do that, you should come up with, for 85, a CPI of 1,000. For 2015, you're going to get 2410. Okay? In each case, we are simply taking this equation and plugging in the numbers that we're given. Okay, so notice what we've been talking about is the price level, okay, or the price index, which we're pretty much using interchangeably. What is inflation? Price level and inflation are different things. They're closely connected, but they are not the same thing. Inflation refers to an increase in the average level of prices. We've been talking about the price index. We have inflation when that index value is going up. Likewise, when we have an increase in prices, we will also have a decrease in the purchasing power of money. It's really, these two things are really just different ways of saying the same thing. If prices are going up, then that means it takes more money to purchase any particular good. For example, if the price of a hamburger is $1, then what's the purchasing power of a hamburger of $1? What can you buy with it? One hamburger. If the price level doubles, so that now you have to have $2 to buy one hamburger, then $1 will now buy only half a hamburger. If the price level doubles, then the purchasing power of money is cut in half. Prices go up, purchasing power of money always goes down. Remember, purchasing power of money, that phrase just means the amount of goods and services that you can buy with one unit of money. So higher prices and lower purchasing power of money. That's really the most important thing to remember about inflation. So we have inflation with prices in general are going up. How do we measure how much inflation we're having? So we do that with the inflation rate, which is the annual rate. Almost always we measure it as a yearly rate. The annual rate at which the price level is changing. How fast is the price level changing? Okay? So the price level shows us where prices are at a point in time. The inflation rate shows us how fast that price level is changing. And when we have inflation, it means that prices are going up. And the higher the inflation rate, the faster prices are going up. Inflation rate is the percentage change in a price index from one year to the next. And this is the equation that you would use to calculate the inflation rate. Now, this isn't really a new equation, because before we talked about growth rates, measuring the growth rate of GDP or real GDP. And it was just, you wanted the growth rate, it was the change in GDP divided by the initial level of GDP. Well, this is just taking that same growth relationship and applying it to prices. The inflation rate for year 2 is going to be the difference between prices at the end of year 2 and prices at the end of the previous year. Okay? So the numerator there is giving us the change that occurred. And we want to express that change as a percentage change. And anytime we want a percentage change, we divide the change by where the variable was at the beginning of the interval. So since we're starting with year 1, we divide by the price level for year 1. Notice whatever year is here, exactly the same thing is down there. So it's the change in prices over that interval divided by the price level at the beginning of the interval. And we multiply by 100 to get the, to express it as, to convert it into a percentage change, right? And that works for any 2 years. It doesn't matter which years we're looking at. They would not necessarily have to be consecutive years. You could look at the change in prices between 1900 and 2000. It would work there. But generally, when we're talking about inflation, we do look at a 1-year period. This is a diagram from your book that I think is really useful in helping you think about inflation. They call this the inflation elevator. Okay? When you have 5 people in an elevator, okay, when the elevator goes up, they're all going up. Okay? Goes down, they're all going down. Well, when you're thinking about inflation, we're talking about what's happening to prices as a group or on average. Now we know from chapter 3 and chapter 4 on supply and demand that every year some prices go up, some prices go down. Okay? And that's what you see in this graph. They show some prices going up, some prices going down. But they're assuming that in this first year, the average price is at 100. So that's where the average is. When you have inflation, it doesn't mean that every single price is going up. It means that on average, prices are going up. So the inflation car is going up. It's going to a higher level. Notice some of the prices for some of the goods in the elevator will go down. But if you're having inflation, that means that on average, prices are higher in the second year than they were in the first year. Don't ever think that inflation means everything is becoming more expensive. Inflation means that on average, prices are going up. Things are becoming more expensive. Okay, and here's a test. If the price index is 200 in year 1 and 210 in year 2, what is the rate of inflation? How would we calculate that? Remember our equation. We said the inflation rate is the difference between the price level in the second year minus the price level in the first year divided by what? Price level in the first year. This is the change that occurred, and then we're expressing it as a percentage of the original level, and then multiplied by 100. So if you plug those numbers in, the price index went up by 10, but 10 here, but we're dividing by the initial price level, which is 200, so that comes out to a 5% rate of inflation. The government calculates a number of different price indices. The CPI is the one you hear the most about, but there are a number of others. I'll just mention some of these others. Consumer price index, as I said, tries to measure the price of a basket of goods bought by the typical American family. And we said that it does, the BOS divides those into 8 different groups. A second price index you will hear about is the GDP deflator. If you recall back in chapter 26, we talked about that a little bit. It is a broader price index. It doesn't focus on what the typical American family buys. It is broader in the sense that it includes all finished goods and services produced in the economy. Whether the Americans are buying those goods or whether people in other countries are buying, it's not important. It's a much broader thing, whereas the consumer price index is focused on what does the typical American family purchase. Producer price index is another index. We're not really going to say anything about that. PCE index is one you want to remember. That stands for personal consumption expenditures, but you can just remember PCE. And the thing to remember about the PCE index is that that is the Federal Reserve's favorite measure of inflation. Generally, when prices are going up, all of these will be going up. They will be similar, but they don't always increase at the same rate. The Federal Reserve, it's one of their most important jobs is to focus on inflation and keep inflation down. Okay? And so they're very interested in how much inflation are we having. And so it's important to know, well, if these price indices are behaving differently, which one is the Fed going to focus on? And the Fed is going to focus on this one, the PCE index. This chart is useful to look at. 1950 through 2016. This is the inflation rate. You can see that it has fluctuated a lot. Okay? We have had periods where prices declined back in around the late 40s, early 50s, a little bit. And we had inflation. You see a lot of instability. Notice between 65 and 80, you had this big increase in inflation. It's sometimes called the Great Inflation, because inflation was increasing, and it was our prices were increasing, and they were increasing at a faster and faster rate. And I remember when I had my first economics course, it was during the latter part of the 70s. We were right in here. And I remember my teacher saying that he believed that we were just going to keep going like that. It was very disturbing. You can see that it didn't happen. Inflation came down, and it has been, since the 1990s, it has been rather low and relatively stable. Notice we had a big drop prior to 2010. That corresponds to the financial crisis in 2008. But generally, inflation has been very, very low, okay? Which leads some people to think we don't need to worry about inflation because look at the past. Well, we really don't care about the past. We're interested in the future. The problem is we don't know what the future will be. So we look at the past to get an idea of what the future may look like. The problem that many people have is that they only look at the part of the past that they are personally familiar with. Okay? And so if you haven't thought about economic things prior to 2000, then you would only be seeing this part. You'd say, oh, inflation is not a problem. That's not going to be a problem. But if you're thinking longer term, then you see that inflation certainly can go up. So it's important to have some understanding of the long run history of inflation in this country. It has bounced around a lot if you look at longer periods of time. As it's been pretty stable over the last 20 years, but anything can happen. When we talk about the real price of something, real is a term that we have used before. We talked about real GDP. And when we talked about real GDP, what did we mean by real? It means it has been adjusted for inflation. That's important to remember. Anytime you hear real anything in economics, it means it has been adjusted for inflation or corrected for inflation. So when we have a real price, that simply means we've adjusted it for inflation. Real prices are used to compare prices of goods over time. Okay? Anytime, we said this back with GDP, but it's true more broadly. Anytime we're going to compare numbers in different years, we have to adjust for inflation. If we don't, our comparisons are going to be meaningless. So it's going to be very important to know, how do we correct for inflation? It's very important, and thankfully it's very easy to do. If you have the right data, it's very easy to do. And here's the example we're going to use. Consider two presidents appropriate, it's election day, so we're talking about presidents. Who was paid more, John F. Kennedy or George W. Bush? Kennedy was paid $100,000. Bush was paid $400,000. You might look at that and say, well, it's pretty obvious. Bush was paid 4 times as much. He got $400,000. Would you agree with that? No. It's if we're only interested in how many dollars did he get, well, obviously Bush got more. He got 4 times as many dollars. But when we talk about who was paid more, we're not primarily interested in how many dollars did they receive. We're interested in the purchasing power that those dollars represent. And purchasing power depends on how many dollars do you get, but also on what are the prices you have to pay when you go to the store to buy stuff. And we have to recognize that this is Kennedy's salary in 1961. This is Bush's salary 40 years later. Should we just assume, well, prices probably didn't change? Well, no, we know prices changed. We know that they went up over that 40-year period. What we need to think about is who had greater purchasing power, and how do we figure that out? And what we need to do, we need to convert into dollars from the same year. Notice, this is his salary in 1961 dollars. This is Bush's salary in 2002 dollars. Those are not the same dollars because prices were different. So we cannot compare these two numbers directly. In order to compare them, we're going to have to convert. We're going to have to take Kennedy's salary, which is $61, and convert it into 2002 dollars, or we're going to have to take Bush's salary and convert it into 1961 dollars. And it turns out that you can multiply and divide, you can do that conversion. Here's the relationship you want to remember. And there will be probably several questions on the exam where you have this equation and you can plug numbers in, punch them into your calculator, you will get the right answer. Anytime you're comparing amounts in 2 different years, all you have to do to convert into real terms is take the number you started with and multiply by a conversion factor. And the conversion factor is always a ratio of CPI numbers. The only thing that where you get tripped up is you do have to remember which year goes in the numerator and which year goes in the denominator. Notice here we are converting into 2002 dollars. And so that is the year that goes in the numerator. The year you're converting into, the CPI for that year goes in the numerator. Okay? And what goes in the denominator? The CPI for the other year. So we're dealing with year 1 and year 2. So the CPI for year 1 goes in the denominator. That's all you have to do. Multiply and divide, and that will convert into dollars in whatever year you want to use. Okay? So let's think about what we have here. We've got Kennedy got 100,000, but it was $61. Bush got 400,000, but it was $2,002. If we want to be able to compare in a meaningful sense, we need to know this, okay, We need to know what was Bush's salary in terms of $61. Because if we know that, then we could compare these two numbers. Or if we knew what Kennedy's salary was in terms of $2002, that would work as well. If we knew this, then we could compare these two numbers. Because we can compare $61 with $61. We can compare $2002 to $2002. We can't compare $61 with $2002. We have to make a conversion. And here we're showing we could do it either way. It doesn't matter whose salary we convert. We just have to get both salaries in terms of the same dollars. What happened to prices over that 41-year period? Well, this is 1960. 2002 was somewhere in here, and this is the CPI. So you can see that we had constant inflation. Clearly, prices were higher in 2002 than in 61. Now, before we do the calculation, think about what does that mean? Bush received 4 times as many dollars, but prices were high. So he had to have more dollars in order to have the same purchasing power as before. So if all we know is that Bush got 4 times as many dollars, and we know the prices went up, but if we don't know how much they went up, then we have to say, well, we really don't know who had more purchasing power. But if we have the CPI for each year, then we can do the calculation and we can figure out who was actually paid more. Okay? And here's what we need to do. This is what the 100,000, 400,000, that's what we had before. The calculations we need to do we can do this calculation. Okay? That would be taking Kennedy's salary and converting it into $2002, and then compare that to this. Okay? That would give us an answer. Or we can take Bush's 400,000 2002 salary and convert that into an equivalent 1961 salary, and this is how we would do that. Okay? And if we know this, then we can compare that to Kennedy's 61 salary. So we can compare these numbers, or we can compare these numbers. It doesn't matter. We're going to get the same answer either way. Now, if you had to figure out what the CPI was in each of those years, then that would be a hopeless job, because that requires getting lots and lots of data from lots and lots of people. But the CPI numbers are published by the government. They've already been calculated. So it's not hard to find them, especially with Google. What we find is that in 1961, the CPI was 29.9. In 2002, the CPI was 179.8. Okay? Notice Bush was paid 4 times as many dollars. But by how much did prices go up? They went from 30 to 180. So prices went up by almost exactly a factor of 6. So just guessing, who does it look like got paid more? It's going to be Kennedy, because Bush got a lot more dollars, but he didn't get enough extra dollars to compensate him for the prices that went up even faster than at a rate of 4 times. So we've got this is the equation we need to use, or this one, either one. Notice they have the same numbers. It's just that they are flipped. If we're calculating Bush's salary in $61, and we use the CPI for 61. Whichever year you're converting into, that goes in the numerator. Going over here, we're calculating Kennedy's salary in terms of $2,002. So in the numerator, you have the CPI for 2002. Take this data, plug it into these equations, and these are the results that you get. Kennedy's salary in terms of $2,002 over $600,000. Think about what that means. This number is saying that in 1961, Kennedy received a salary of $100,000. And given prices in that year, there's some amount of goods and services he could have bought with $100,000. This number is saying that in 2002, to have the same purchasing power that Kennedy had with $100,061, you would need over $600,000. This is saying in purchasing power terms, getting paid $100,061 and getting paid $601,000 in 2002 is exactly the same. They were equivalent. You're getting paid $601,000 in 2002. You're getting a whole lot more dollars, but your purchasing power, if we've done our calculations correctly, your purchasing power would be exactly the same as Kennedy's $100,061. Right? So we can, in terms of this calculation, who was paid more? Well, Kennedy was, because we can compare this number with this number. In terms of $2,002, Kennedy was paid $601,000. Bush was paid only $400,000. So not only was Kennedy paid more, he was paid 50% more in terms of purchasing power. I like this example because it shows how important it is to adjust for inflation. Because if you don't know to adjust for inflation, then you would look at the 100 and the 400. You'd say, well, Bush was paid a whole lot more. But when you adjust for inflation, you see, no, he wasn't paid more. See that Kennedy was actually paid more. Also, if we instead focus on our Bush's salary in terms of $61 and compare that to Kennedy's salary in 61, again, we see that Kennedy was paid more. He had equivalent, had 100,000. Bush's salary was equivalent to only 66,000. So again, we see Kennedy was paid 50% more in terms of purchasing power than was Bush. One more thing to point out, comparing these two numbers, be sure you understand what this means. The 400,000, that's what Bush was, what he received in 2002. This number is saying in 1961, to have the same purchasing power that Kennedy or Bush had in 2002, you would only need $66,500. Purchasing power terms, this number and this number are equivalent. Okay? Now, those are important things to understand and to be able to do the calculation. So who was paid more, Kennedy? Another question to think about, how much would you have to have been paid in 2019 to have the same purchasing power that Kennedy had in 61? Think for a minute. Try to write down what is the equation you would use to calculate that. Same equation we used before. We would be trying to figure out what is the amount you would have to receive in 2019. We're trying to figure out what would be equivalent in 2019 to the amount that he received in 61. And if we're converting into 2019 dollars from 61, then what's the conversion factor? It's just a ratio of CPI numbers. The numerator is the year you're converting into. The denominator is the year that you're starting with. So if you have that information, you would just plug those numbers into the equation. And it turns out we already had the CPI for 61 was 29.9. CPI for 2019, if you Google that, comes up to 255.6. Multiply that out, you get $854,000, which means, think about, anytime you do a calculation, think about what does it mean? It means that in 2019, to have the same purchasing power that Kennedy had with his 100,000 in 61, you would need almost $900,000. It shows you how important it is to be aware that you have to adjust for inflation. If you're talking about the price of a good, if you're talking about GDP, if you're talking about salaries, if you're talking about dollar amounts in different years, you have to adjust for inflation. And this is the way to do it. Not very complicated. You just multiply by a ratio of CPI number. You have to remember what goes in the numerator, what goes in the denominator. You can do that. You can multiply and you can divide. Then you can do this calculation. Any questions on it? Okay, this one extra example. Price of gasoline. 1982, the price was $1.25 a gallon. If you tempted to think, wow, that was really cheap, you have to adjust for inflation. 2006, it was $2.50. When was the price higher? You have to convert into real terms. You have to take the 82 price and convert it into 2006 dollars, or you have to take the 2006 price and convert it into $82. Either way. If we take the 82 price and we try to find what would it be in terms of 2006 dollars, then we take the 125, we multiply by the ratio of the CPI in 2006 over the CPI in 1982, and we get 253. What does that mean? It means that in 1982, the price was $1.25 at the time. But if we want to adjust for inflation and compare to the 2006 price, this is what we do. We come up with the real 82 price is 253, which is a little bit higher than the 2006 price. So the 82 price in real terms was higher than the 2006 price, although in just the nominal terms, it was only half the price. You have to adjust for inflation. Okay, we've got a few more minutes. Inflation is important to recognize that it varies over time, and it varies from one country to another. Here you have selected countries. You can see 2016. These are the two countries that had the highest inflation rates, 476% for South Sudan and Venezuela. Think about what that means. It means prices started the year at one level, and the increase was basically a factor of 5. So you would end up at the end of the year with prices really being 6 times what they were at the beginning of the year. Obviously, that's not what we mean by price level stability. In the United States, the CPI was, inflation rate was a little over 1%. see a lot of countries have low inflation. A few had deflation. This is an interesting chart. Hyperinflation. That is a term that gets thrown around a lot. It's not a official definition for hyperinflation, but sometimes it is defined as a monthly inflation rate of over 50%, which translates into an annual inflation rate of over 12,000%. And here are a few examples of that. In this country, the latter part of the 1770s, the maximum inflation rate on a monthly basis, 1,300%. That was during the Revolutionary War. The government was spending lots of money to fight the war. Where did they get that money from? Well, they were just creating lots of money. You have government creating lots of money, that tends to cause prices to go up a lot. And here you have other examples of high inflation rates. Notice here, Hungary, right after World War II, cumulative inflation rate, the annual inflation rate, 1.3 times 10 to the 24th power. I don't even know what you would call that, quadrillion, something like that. Just rates of inflation that are hard to imagine, where everything tomorrow costs twice as much as it did today. Just imagine how that would make life difficult. If things were going to be twice as expensive tomorrow as they are today, what about next week? What about next month? You can have enough money to live, to pay your tuition. You know, life becomes very, very difficult and confusing when you have high inflation. We don't think about that because we haven't had high inflation. But when inflation starts going up, it becomes very quickly becomes a very serious problem. A real price is a price that has been corrected for inflation. Okay. Second part of the chapter has to do with what is called the quantity theory of money. It deals with the relationship between the quantity of money available in the economy and the price level. And it's kind of a complicated relationship, although we can express the quantity theory in a pretty simple equation. We'll stop on this. Quantity theory equation is this. M times V equals P times Y. Most of those letters are not new. They are familiar to us. M just stands for the money supply. How much money exists in the economy at a point in time. Now on to P. P represents the price level. That's what we've been talking about today. Y represents GDP, and the subscript R means we're talking about real GDP. So M, P, Y, R, those are not new. The only thing that's new is V. And V stands for the velocity of money. The velocity of money is the number of times that an average dollar is spent during the year. So in one sense, it's a very simple concept. How many times was the average dollar spent during the year? Let's give you one example and then we'll stop. Let's say that you have an economy where the money supply is 7 trillion. Okay? That's how many dollars exist in the economy. Let's say that real GDP is 21 trillion, meaning that during the year, $21 trillion worth of output was produced. How could $7 trillion of money, or how could $21 trillion worth of output be purchased if people only have $7 trillion of money? How can you have 21 trillion bought with only 7 trillion money? Well, obviously, each dollar had to be spent more than once. So if we have this situation, that would mean that the velocity of money would be what? Would be 3. On average, each dollar was spent 3 times during the year to buy output. And you probably don't see where this is going, but it actually is a very useful idea. What we're going to see is if we make one assumption, 2 assumptions, then we see a very, very close connection between money and prices. And this is exactly the equation we need to help us think about what might be the consequences of the Federal Reserve financing trillions of dollars of spending by the government. That's what they're doing. What will it lead to? Well, this equation helps us to think about that question. It's not going to give us a simple answer, but at least we can see what could happen, how to think about those possibilities. Okay, we will continue. We will be talking about the quantity theory of money next time. Possible we'll get into chapter 32 some, but primarily we'll be in chapter 31. Right. I think it's in here.